OK, good afternoon, Web Summit. Welcome to AWS Developer Workshop. My name is Boaz Zinnemann. I'm a technical evangelist with the AWS team. And we are going to talk this afternoon about IoT, about Internet of Things, and how we can help companies to build more sophisticated systems using IoT. And today we see IoT basically everywhere. We see startups and large enterprises trying to build IoT solutions. And they're building those solutions to be able to provide new types of products, new capabilities, connect physical products with virtual products, connect physical records with something coming from devices all over the world. And many of the companies that are developing IoT solutions are doing that for the data. Because you can start getting new types of data when you have sensors in places where there was no way to get data out of there. If it's here in your home, if it's in vehicles, if it's in soil, water, whatever you can imagine. And the price of those devices is going lower and lower every year. And we see a huge expansion in this area. But, and there is a very big but here, IoT is complicated. It's relatively hard to take this concept and build an IoT system end-to-end from the tiny device or sensor to getting the data, analyzing, acting upon this data. And we're constantly looking for ways at AWS to make life simpler to our customers. And specifically, when we're talking about IoT, how do we make IoT simpler for developers? And this is what we're going to focus today on the development world. How do we focus on developers, and how can we provide tools for developers to create better, more successful IoT products? And how can we make a system that will allow two guys in the garage building a super smart toaster to be able to create this system in a very secure way, to make sure that this toaster won't be the next botnet like it happened a few months ago with smart cameras or something like that. How can we make those two guys create a scalable system that can scale from several dozens of devices that are distributed between friends and family to a real product that can be distributed globally and having thousands, hundreds of thousands, millions of devices connected to the cloud? And the way we see IoT today at AWS includes three different layers. On one layer, we have our things. It can be devices, it can be sensors that can send and, in some cases, act. On the other end, there is the cloud. And the cloud provides the storage and the computing power that is very lacking in those devices. Those devices are usually very, very small. They have a very basic processors, very basic storage. And the cloud basically extends the capabilities, the computing capabilities, into something that is unlimited. And the third thing, and sometimes the most important thing, is the intelligence. Is the thing that connects everything together. The ability to understand the data coming from your devices and take decisions with this data is something very important for our platform. And we are going to talk today about several parts of this IoT platform on AWS. And when we look at the architecture, there are several components that we should be familiar with. And I want to start with the two main ones and talk first about AWS IoT Core. So AWS IoT Core is the part that allows you to connect devices to the cloud. We're going to talk about the different parts of AWS IoT Core in a second. But in general, this is the component that will allow you to connect your devices, stream the data, store it, act upon it, and analyze it. The other part is your devices, is basically the edge. And here we're going to talk about two things. We're going to talk about Greengrass, and we're going to talk about endpoints and microcontrollers. And the idea is, how do I connect those devices in the simplest way possible into the cloud? And there are many ways to do it and many technologies that support it. In addition to that, we provide some additional features and capabilities to manage your fleet and deal with everything related to onboarding and management of large IoT fleets. We have a component that takes care of security, auditing, and protection for those large fleets, and this is a very big challenge in the IoT world. How do I secure my fleet? How do I secure my network end-to-end? How do I make sure that the data I'm getting into my system is authenticated and valid? And this is another tool you can use. And last but not least, IoT data analysis that will allow you to take the data coming from your devices and connect it into additional AWS services like databases, data warehouse, analytics, so on and so forth. So let's focus, first of all, on the first part and talk about AWS IoT Core. And when we're talking about AWS IoT Core, we're basically talking about the ability to connect your devices into the cloud. And this tool, this system, has many features that you should be aware of that will allow you to achieve that in a very, very simple way. So first of all, we're talking about identity services. One of the most important things in IoT is to make sure that your devices are connecting securely to the network. And when we were used to build web systems and used to do SSL and HTTPS, the thing that I wanted to make sure is that the site I'm getting to is actually my bank. Okay? So the bank issued a certificate, put it on his website, and I was able to tell if this is the bank or somebody that is supposed to be my bank. With IoT, the challenge is much bigger. I need to make sure that not only I'm connecting to a secure network, but that this device, let's say this clicker is my IoT device, is actually allowed to do that. And this is called mutual authentication. And when you're doing mutual authentication, you're basically making sure that both ends of the system are talking securely with each other. And this is something you can manage with our identity services. When we talk about device gateway, the device gateway will allow you to stream data into the cloud. It can support multiple protocols. It can support HTTP, and it can support MQTT, which is very, very popular. It can support WebSockets and allow you to stream the data. And when this data arrive into your system, you can use the message broker and then decide in a very simple ways how to route this data. Where should I store it? Into which topic? It can support publishing data. It can support subscribing for reading data. It can support quality of service. And you can query topics to find data based on paths, same as in file systems. So you can define your own data structure. So if I'm building now my system for my smart home, I can define my home as a whole as the root folder, divide my rooms into subfolders, and then divide devices in each room for streaming data for a specific device. That will allow me in a later stage to query based on my entire home, based on a specific device, or based on a room by providing a path into the specific message. The next feature is registry. And registry will allow you to store information about your devices, like device ID, like firmware version, or anything you need to know about the different devices on your network. You can basically design your own patterns of what you would like to store in registry. And this is static metadata that you're storing into the cloud. And you can basically split those devices into groups and have some rules based on those groups and many other things. Another super important thing when developing IoT solutions is device shadow. So the idea behind device shadow is that I don't want to develop systems that are talking directly to my device. If I need now to control this lamp, which is very, very bright and killing me, I would like to create a system that will be able to control this light but not talking to this light directly. And there are many reasons for that. Some of them are related to security, some of them are related to connectivity. And device shadow allow you to have a virtual representation of your device inside the cloud. And when I'm writing my application, I'm working with my application against this shadow. So if I'm now running an application on my iPhone and want to control this lamp, which I'm going to do in a few minutes, not this one, another one. Basically, I'm changing the device shadow. The application will tell the device shadow to change from 100% to 50%. The device will read this shadow, will make this change, report back that the status was changed to 50%, and then it will be reported back to my application. And this is how I'm closing the loop. And if by mistake or because of some problems, the device is disconnected, nothing will change in the shadow until the device will be reconnected, read the shadow, and close this entire loop. I would like to show you a very, very short demo. How do we work with shadows? And for that, I'm going to need your mobile phones, so take them out, please. This is the kind of talks that you're allowed to use your phones during the talk. And if you would like to scan this QR code or use this URL at the top, and people on Twitch are more than welcome to join us as well, because it's going to work globally. We're going to place with some virtual lights. It will be really, really cool if you can hold your phone up so the cameras can see you, because we're going to play with it in a second. And I'll give you 2 more seconds to scan it. We're good? Can we start? Let's play. OK, you have the URL here as well, so in case you were not able to scan it, go to bit.ly/AWS IoT Lights. Just make sure that you're doing the right capitalization, so you actually can get to this page. So each one of you is connected into my smart lighting system. And I'm the controller. I can turn on and off your lights in a click of a button. So now everybody has their lights turned off. And if I'm going to here and going to click put brightness to 100%, what happened? Show me, I can't see it. Do the other way around so the camera can see it. And now I obviously can play with it. I can put it to 52%, and it will go down. And if you're going to follow my changes, you're going to see that it's happening really, really quick. And what I'm doing here is playing with device shadow. I'm changing the device shadow of this specific lamp. Your phones, and there are probably a few hundred people connected right now to this shadow, are reading the information from this shadow and changing it accordingly, reporting back that it was changed. I can shut it down, and I can turn it on again. I hope people on Twitch are playing with this as well and can actually see how it works. There is an autopilot here. I'm going to leave it on autopilot so it can go up and down a bit automatically. And this is basically how I control a smart device with device shadow. So let me show you how it actually works behind the scenes. So my phone is the controller, and you can see it here on the right. This is the control application, basically my smart switch, if you want. It will get some credentials from Amazon Cognito to allow me to connect securely to the cloud. So I actually getting credentials to do this operation of accessing and changing the shadow. It's connected to AWS IoT Shadow, and each time I'm changing something on my app, it will change here in the shadow. Your phones are reading this information to AWS IoT, and each time I'm doing a change in my shadow, your phone, your application, the application on your phone will change the light accordingly. Pretty simple, right? So this is the basic idea of shadow. I can obviously add some more capabilities to that, like adding a third-party application or adding Alexa to that. And in very few lines of code, I can add an Alexa device with a very simple skill and tell Alexa, Alexa, turn lights to 50%. It will change the shadow to 50% by using an AWS Lambda function. And if you've been here in some of the serverless talks we did during this week, so you're probably familiar with Lambda. If not, this is a way to run code in the cloud without servers. So I can write a very, very simple code that all it does is waiting for instructions from Alexa and changing my shadow into the number in this specific command. So this is how it looks schematically. And if we are looking at our console, and this is how AWS IoT console look like. So basically, I'm managing all my devices from here. I can show you my things. So I have several things here running in North Virginia. This is the IoT lamp thing that I'm managing. Obviously, this list can be hundreds or thousands of devices. And when I'm going into a specific thing, I can go into shadow. And as you can see, this is my shadow representation. If I'll go to my management app and put it into 50%, my shadow will change to 50%, and I assume your lamps will turn on into 50%. I can actually simulate something similar by editing the shadow directly. I'll increase the font a bit. So I can edit the shadow directly, set it up to 100, save, And theoretically, all your lamps should be now in 100%. Right? I don't see it. Cool. So this is how shadow works. And this is one of the most important parts when you would like to connect your things into real-life applications and connect your things into legacy applications. So in many cases, working through shadows makes your life much easier. And this is just one example and one feature of AWS IoT. This is Alexa coming back to the slide. So we're not done yet with AWS IoT Core. There is one more feature that is called the rule engine, and it's a very important feature. So the rule engine will allow you to run queries against the data coming from your devices. SQL-like queries with select, from, where, like we're doing with regular SQL. And it will allow you to take the result of this query and put it somewhere else. You can stream it to other services. You can store it into a database. You can decide to act upon this information with a Lambda function. You can put it into an analytics system. You can send an SMS or an email based on this information by running a very, very simple query. And you can even connect into external services and enrich your information. So for example, if information is coming in with certain type of data, I can read another table, another database, even a machine learning model, and enrich the data coming based on this specific query and connect it to many, many other AWS services. And this is a very important feature, because when you're developing an IoT application, the rules are the thing that define the way your application works. And I'm just going to give you a very simple example. So BMW are developing a project called the Connected Car Project. It's a car with a lot of sensors and devices connected into AWS IoT. Okay? So when I'm sending data like my speed, the music I'm listening to, the air conditioning, is a data that is very nice to have. I'll store it, I'll put it in a database, I'll show nice dashboard to the driver at the end of this drive, mail it to his email, post it on Facebook, whatever. But it's nice to have. But if my car senses that I'm driving on ice, for example, and apart from all the things it will do, mechanically adjusting traction and many other things, I would like to send a notification for all other connected cars in my area that this area is a very dangerous place to drive in. So the rule that will implement this will be completely different from the rule that I was talking about before of the nice-to-have data. I want this dangerous condition rule to act immediately. I want it to send a message to all connected cars in the area based on the information coming from different services. And this is something you can achieve very, very easily with a very simple SQL query with rule engine, and then create an action based on this query. So by using AWS IoT Core, you're getting a lot of advantages out of the box. First of all, we are taking care of the security end-to-end of your application and of your devices. You will be able to connect applications, if it's new applications or legacy applications, into your IoT devices. And this is a huge challenge for enterprises and companies with major setups with very large systems that are already working. We are able to route and process information coming from your devices in a very simple way. And one of the most important things, and one of the things that I've been using a lot, is the fact that by using AWS IoT Core, you're getting a very simple way to connect to all other 120 or 130, or I don't know the exact number right now, of other AWS services out there. Databases, analytics tools, queuing, messaging, and many, many others. So this is a huge advantage of this platform, and you should take it into account. And we have many customers using it in many different ways, and we're going to talk about several of them today. But let's just take one example, a solution for petrol stations. So petrol stations used to work for ages in a very certain way. And today, with a lot of sensors and a lot of IoT inside those stations, analyzing this data, people can start managing their petrol stations proactively rather than reactively. And this is a very big change, and this is the type of change that IoT data can bring to the market, and EMS is one of our customers that are doing that. I'm going to show you some very interesting examples later on in this presentation. So that was AWS IoT Core. Now, let's talk about the other side. Let's talk about things. And when we're talking about things, we're talking about devices working out there. It can be in many, many different places. It can be in your home, it can be in your car, it can be in the field, it can be in space, it can be under the water. And you should take this into account. And when we're talking about those devices, our challenge is how to extend AWS intelligence to the edge. How to bring the capabilities of the cloud to a device that costs $2, $1.50, maybe less today, and still needs to operate in a secure, scalable way. And when we talk about things and how things operate, we need for every use case to decide if you want to do the data analysis in the cloud or at the edge. And when making those decisions, there are three patterns that pop up. We call them laws. And you should take those laws into account. So the first law is the law of physics. So considerations like speed of light. OK? Speed of light is limited. You can't beat speed of light. And sometimes you need to send information faster than that. And connectivity issues in places like space, air, oceans is a very big challenge. And there are challenges that you simply can't break. And this is just one part. Economics is another part you should take into consideration. Data has cost. Moving data from your devices into the cloud can cost you money. Actually can cost you a lot of money. And in some cases, you would like to make the processing locally before sending anything out there. And the last thing is privacy, or the law of the land. There are rules, there are regulations for storing data, for having copies of data, and how to manipulate this data. And in many, many cases, you won't be able to send your data to the cloud because of very specific laws and regulations. And when we're usually talking about these laws, the context is pushing the decisions into the edge. But you must remember that it works both ways. And when you're making this decision of where should I put my workload, it goes basically both ways, and you should take this into account. Just to give you one example, so in terms of economics, those devices may store a lot of data, and they may send a lot of data. But the cloud is probably one of the things with the cheapest storage and hardware out there. And you might want to take advantage of the cloud for your data analysis and data storage, regardless of the fact how much it costs you to send it into cloud. So you need to make the decision right, and you need to make the decision where should I put my workloads based on every use case and based on your exact needs. And this is AWS, so we'd like to give you options. We'd like to give you options to build your solution the way you need to build it. And we're giving you a lot of them. And one of the advantages is that by operating on our platform, you're basically working with a very common programming model. And you can reuse techniques and technologies that you're already using in other places. And this is a very big advantage. And when we're talking about AWS Greengrass, this is your extension into the cloud. AWS Greengrass takes whatever we provide with AWS IoT Core, many of those capabilities, and extend it to the edge, and allow you to connect those devices and work with AWS Cloud locally. And we see Greengrass in almost every industry, and I'm going to give you several examples. And we see it in industrial gateways and medical devices, in energy and retail and automotive. And we see a lot of Greengrass implementation in automotive because of a very interesting fact. Somebody wants to guess how much data an autonomous car generates in 1 hour. You need to shut up. Shut it really hard. One guess? Megabytes? Terabytes? Terabytes. Good. How many terabytes? About 40 terabytes. 1 hour. autonomous car, 40 terabytes an hour. Now, what do you do with 40 terabytes an hour in a car? It's a driving data center. You need to have a rack at the back with endless arrays of disks. So you're taking these 20 terabytes, and then you're doing compression. It becomes 2 terabytes, which is nice, but still, this is 1 hour. If I need to drive for 10 hours, I need probably several hard drives in this car. But then when you're doing local processing in the car, the data that really matters compressed into 20 gigabytes. And this is something I can work with. I can store it locally. I can upload portions of it to the cloud for further analysis. And basically, this is something that people are doing today locally on the devices. And there is no way to work distributed with numbers like 40 terabytes. And you can find Greengrass in very interesting place that you never thought about. Agriculture, for example. And this is another history that you might not think about it like an IoT-related one. But we see a lot of IoT devices today in agriculture, in everything related to soil quality and automated watering system, and auto-driving combines, and even fish farms. And one of our customers is creating a system for filtering system for fish farms. And today, they're connecting some of those farms with AWS Greengrass because many of them are placed in locations where there is no access to the internet, or the internet is working part of the time. And this is provide them the local connectivity for all the sensors into Greengrass. And let me explain you what Greengrass is. So basically, Greengrass is a software installed gateway. You're taking a machine, installing Greengrass on top of it. It's a software product. And then you're able to connect your devices into Greengrass. And it can support different architectures. It's running on x86 and ARM and ARM 7 and 8. It's Linux-based, and you can install it on Amazon Linux or Ubuntu, or even on Raspberry Pi. And a lot of our customers are using Raspberry Pis for Greengrass. This is probably the easiest way to deploy Greengrass, but you can install Greengrass on a rack. You can install Greengrass on the tower or on any server. And core devices has AWS IoT SDK that allow them to connect directly to Greengrass. And when you install Greengrass, what you're getting out of the box is basically the expansion of the cloud into your local device. And it will allow you to do local actions with Lambda. You can run Lambda functions locally on your device. It will allow you to do local triggers based on data coming from your sensors in your internal network. It will do data state and sync, and it will allow you to store data when your Greengrass device is disconnected and replay the data when you get online again. And of course, all the security that you saw in AWS IoT Core in a local device. But there are some additional features that are related to devices working at the edge, like over-the-air updates, the ability to send updates to the system over the air, or support for protocols like OPC UA, which is a super popular protocol for industrial machinery. And of course, local resource access. You can access your USB ports with cameras and sensors. You can access local storage. You can access network storage or anything else connected to your devices. And last but not least, and something very important to many of our customers, is the local machine learning inference. And local machine learning inference is basically taking machine learning and bringing it to the edge. And it will allow you to take and build and train machine learning models in the cloud when there is the capacity, the data, the computing power, which is not available at the edge, and then use Greengrass to deploy and optimize those models on your end devices. And then connect anything you have, like cameras or industrial machines, and do machine learning inference on the edge. And of course, that will allow you to make much quicker decisions. Just think about a situation when you're driving your autonomous car and the autonomous car decides that it has to brake. If it will have to wait for the data to go to the cloud and back, it will be way, way too late. Okay? And you don't have a choice but running it on the edge. And this is one of the things you can do with implementations like Greengrass. And we have already today many customers and many partners working with us on Greengrass implementations. Some here are partners that providing devices supporting Greengrass. Some of them are customers. And I would like to give you an example of one of our customers running Greengrass, and this is Rio Tinto. And usually I was telling the story of Rio Tinto because I love this example. It's super cool. But like a week ago, AWS released a movie about this implementation, and I would like you to see it.
Everything here is big. A mine almost 2 miles wide. 250-ton trucks. Welcome to the second largest boron mine in the world. But when everything is this big, it's the little things that can make a difference. Data on the mine's 20 trucks is collected and analysed. Sensors on the trucks detect bumps and movement, uploading what they find to the cloud. Amazon's Greengrass program then takes over and returns its analysis, here in the form of a map showing how different routes and surfaces affect the tyres on these monster tippers.
You can see a heat map here of our mine pit. Where it's green is a little bit smoother road, and where you have the darker red and orange is a rougher road. So we're able to monitor our road roughness and dispatch our road grading crews to the appropriate areas so that we can optimize the work they're doing in the field. And ultimately, that'll save tire wear on our haul trucks.
And then there's the savings, another big attraction of using cloud services, because Rio Tinto reckons it can save what the system costs multiple times over. Yes, in this case, just in rubber.
You could possibly get up to maybe 40–50% more life on a tire.
So how much money is that for the people at home?
So our tires cost about $40,000 to $50,000. So $25,000 more out of the life of a tire is pretty good.
OK, so this is the example of Rio Tinto. And they're saving money by saving rubber, tires. And those tires, if you heard in the video, each one of them costs between $40,000 to $50,000 per single tire. And by creating this heat map that is based on sensors that are already available on those trucks, they did not invent the sensors. They just connected them into Greengrass on every truck. And those sensors sending the information from to Greengrass. Each time the Greengrass device is coming back online because there is no reception at the bottom of the mine, it will send the information to the cloud. It will be analyzed and create those heat maps. And now they can proactively send teams to fix this red road over here to make sure that trucks that are going there will have much less rubber wear. And this is how you save money with an IoT device. And they did this implementation from the moment they installed the Greengrass device on the trucks until they got the heat map in 2 weeks. 2 weeks. And this is because many of the components were already there and many others were provided by AWS to allow them to connect very, very easily. And when you're switching to Greengrass, you're basically getting a lot of advantages like response quickly to local events. We've been talking about it with connected cars, but it can be with crowd management or security or anything like that. You can operate offline. And as I said before, when you go online again, you can sync the data then. You can stay offline for as long as you want. You can even keep a lot of the data offline or locally because regulation or other stuff. It will be simplified device programming by using Lambda. So if people are already using Lambda, they can apply the same technology into Greengrass. It will reduce the cost of your IT applications. It will reduce the cost of your communication and power in many, many cases, because the less you process, the less power you consume. And of course, AWS great security, same as you get when operating with AWS IoT Core. So this is the gateway, OK? But what about my endpoints? What about those tiny sensors and devices that are running with tiny microcontrollers? It's not Intel CPUs or even ARM CPUs. It's like really, really tiny controllers. with a lot of challenges of communication and power consumption and many, many other things. So for them, we're providing our own version of FreeRTOS. And FreeRTOS is an operating system for microcontrollers, a very popular one, an open source one. And based on FreeRTOS kernel, we provided AWS FreeRTOS. And you can take FreeRTOS and deploy it into your microcontrollers. And it will get you from out of the box local connectivity libraries into AWS Greengrass. So now connecting a tiny device into Greengrass will be 1 or 2 liners. Same goes for cloud connectivities, connecting directly from those microcontrollers into the cloud. So in some cases, I don't need Greengrass. I have good connectivity. I don't have power issues. I can connect it directly to the cloud from several reasons. Security related to connecting the device, identifying the device, and over-the-air updates and code signing coming very soon. Right now, it's in an internal beta. And this is how you can take the power of the cloud and put it on the smallest devices out there. And a great example for something like that is a retail company. So if you are familiar with Warby Parker, they design eyewear. And as a very big user of eyewear, I respect that really very much. And they wanted to do something very interesting. They wanted to take the experience that people have online into physical stores. And they operate in both areas. They operate online, they operate in physical stores. And they wanted to take the things that we are really used to in online, like unique visitors. Super simple, right? Each one of us running a website knows how many unique visitors he had during the last 24 hours. What about physical stores? How do I get foot traffic? How many people got into my store in a physical location? Clickstream is the correlation to stay zones, where people stand and actually took a physical product and tried it. Or add to cart, something that we know to count very, very easily. It's product interactions. It's like deciding which product should I take. So what they did, they basically took a lot of sensors, placed them inside their stores to analyze this data and provide them the same information they're used to and know exactly how to work with from physical stores, same as they've been doing it in the online world. And they decided to use Greengrass because they were able to reuse technology that they already know and like Lambda. And the fact that they can distribute it very, very fast in very large numbers of stores make it very easy for them to apply this technology and get something like that, getting an online world experience in the physical world. And this is just one example. There are many, many others. And as you can see, we have a solution that will allow you to connect your IoT end-to-end from your smallest devices through local gateways to the cloud, and some other services that will allow you to run it in a very massive scale. And this solution was designed for small systems, and I'm playing with it a lot for my home automation and some IoT projects that are just for fun, and for large-scale projects with millions of devices, with customers like Philips running their entire infrastructure, the entire IoT infrastructure, with sensors in medical machines and sensors in patients' homes, and many, many others. And you can basically get this entire flow from things to cloud using intelligence with the different tools of AWS IoT Core and all the rest of the system. If you have any questions, I'll be more than happy to answer questions at this point. There are mics here that will help me to hear you. I have one over here if there is somebody close, and there is a mic coming from the back. Somebody close want to start with the first one? Who has questions? I saw one over there. Yeah, you? The mic is coming from there.
Thanks a lot. My question is...
Can you speak up, please?
Yeah. My question is about startups. Do you have a program to help startups to get this technology? I mean,
yeah, sure. We have a program called AWS Activate. You can actually go just behind us at our booth, talk to our AWS Activate team. We have a very big team over here It's not a program specifically for IoT, but for all AWS services. And if you're a startup working in this area or anything else, if you're a startup in any area, IoT or other, talk to our team. We're here for that. Any more questions? OK, so thank you very much for coming. We have one more talk today before we wrap up the developer workshop at the Web Summit, so join us at 4 p.m. If you did not scan your badge yet, please do it on your way out. We're going to send all the presentations from all the sessions in the developer workshop from all the week and $200 credit for AWS. Thank you very much.